Thank you, Spaff. Yes, my great pleasure to produce Ida. See, Ida and I always joke because I butcher her poor last name, and it's not that hard. Ida Ngambeki, who's an assistant professor of computer and information technology here at Purdue. Ida's research investigates the human factors in cybersecurity and includes cybersecurity behavior, social engineering, cybersecurity education, cyber policy, and workforce development. Ida, welcome.
Hello, thank you. One of these days, you're going to get it on the first try, Joel. I believe in you.
I welcome the opportunities. I always enjoy your speech.
Okay, let me see if I can share my screen here. All right, can you see that?
Looks great.
Okay, thank you. All right, so today I'm going to talk very briefly about industrial control systems security and the educational challenge posed by this field. And my talk is going to be based on work that I actually did with Spaff. So Eugene Spafford and I collaborated on a project to develop a curriculum guidance document for our hub and spoke system to help address the industrial control system security lack. But I'm also going to talk about work that we did with our graduate students. We had four great, wonderful graduate students on this project, and also some work I did with Sean McBride at Idaho State University. Okay, so basically what we found here was that industrial control system security is a problem. It's a massive problem, right? Before we start, I want to define some terms, because going through this, what I've found is a lot of people in the cybersecurity space are really not that familiar with industrial control systems. And so when we talk about industrial control systems, I think sort of the root of it is industrial processes, which basically involve the use of machinery and equipment to create physical goods, usually in bulk quantities. So things like motors, temperatures, pressures, levels, flows, all of those things are what we consider industrial processes, right? And industrial automation is the field that deals with the creation and application of technologies that perform these industrial processes while minimizing human oversight and intervention, right? So that's sort of the purpose. We want as few humans as possible. We want these systems to be able to run on their own. We want them to be able to be robust and resilient. And so there's operational technology, which encompasses the communication and control systems used to automate, manipulate, so acquire information. And this is different from information technology, which I think most of us are much more familiar with, that deals with data. Operational technology deals with industrial processes. And when we talk about operations, we're talking about SCADA, we're talking about ICS systems. So operational technology, or OT, tends to be used as the most broad umbrella term here. Industrial control systems is used interchangeably with operational technology. They're not exactly the same thing. ICS refers to the equipment that enables industrial automation. So programmable controllers, sensors, human machine interfaces, SCADA servers. So it's very similar to OT, but it doesn't incorporate that focus on networking technologies, right? But when we talk about industrial control systems, there's another school of thought that basically says that's equipment used to manage a multitude of computerized systems which interact with the physical world, right? So there are those camps who think of industrial control systems as those systems that are used in industrial processes, those systems that are used to control things like manufacturing, oil and gas processing, water distribution, right? And then there are those who widen the term industrial control systems to include things like the electrical grid, right? Information technology, I think we're all familiar with: computers, networking equipment, software that basically supports decision-making, right? It provides us with information. So what we're talking about, the focus of our project, was industrial control systems security, also referred to as industrial cybersecurity. And basically, these are efforts to ensure the safety, reliability, controllability, functionality, and robustness of industrial control systems and operational technology. So we want it, these are the systems, this is the field that is going to make sure that in the face of threats, in the face of vulnerabilities to computerized systems and networks, these systems, these industrial processes can continue to run. So that's what we're talking about here. And the challenge that we're focusing on is when you look at this, you find that industrial control system security is a major economic and national security problem. I think we all know, we've been hearing all day, cybersecurity, one of our primary national security issues. ICSS is a subset of that. And it shows up in so many ways, right? I think the most famous was sort of the Colonial Pipeline disaster, I think we all heard about, which was a ransomware attack on the Colonial Pipeline that provided oil and gas to over 17 states were affected by this ransomware, and the company ended up paying I believe something like $4 million to get their operation systems back up and running again, right? And there are more and more and more of these attacks every year, right? It's definitely increasing exponentially. And if you talk to companies, you talk to CEOs and CIOs, 88% reported in 2019 that this is 88% of CEOs at companies responsible for industrial control systems, companies that use industrial control systems on a daily basis for their operations. They were concerned about cyber attacks. Most of these companies consider industrial control systems, industrial control system security a major priority, right? 66% of these CEOs and CIOs actually said they expect to be victims of an industrial control system cybersecurity attack within the next 3 years that could result in a catastrophic event, right? And these threats are not reducing. These threats are actually increasing. They've increased 2,000% in just the last 3 years, which is slightly ridiculous. So I think we can all agree it's a major economic problem. It's a major national security problem. And in order to deal with this problem, we need people in the workforce pipeline. We need people trained. We need people with the skill set to be able to design secure systems, to secure the systems that already exist, and make sure that they can hold up to these cyber attacks. And if they do fall victim to these cyber attacks, we need systems that will be resilient, right, that can recover from these attacks. But there is a decided lack of talent in this sphere, in the workplace, right? The current national education curriculum lacks essential programs in industrial control system security. If you look at cybersecurity generally, 82% of employers reported the cybersecurity skills shortage. 71% believe there's this talent gap that exposes their institutions, their companies to harm, right? So just to keep up with current demand, there are currently almost half a million open cybersecurity positions just in the United States, right? The cybersecurity workforce needs to grow 89% to keep up with demand in the US, 145% globally, right? So what portion of that is industrial control system security? It's kind of hard to say. We can say about 60% are jobs in operations and maintenance and secure provisioning, which is sort of the area that would encompass ICSS. So I think it would be reasonable to estimate that about half of that 60% is directly ICSS jobs. So that's a significant proportion of the lack of talent in the cybersecurity workforce is because of this lack of industrial control system security professionals, right? So we have this major economic and national security problem. We have a lack of talent that is able to deal with this problem in the workforce pipeline. So where does that leave us, right? That leaves us with looking at the beginning of that pipeline, looking at training and education and saying, okay, obviously there is a problem there. Obviously we are not educating enough people. We are not educating them well enough to make sure that they are able to enter into this space, right? So it's very clear that our current educational efforts are insufficient to address the talent gap in industrial control system security. So we have taken some time and looked at what the educational landscape looks like and where the source of this problem might be. And there are various places, and I'm going to talk about them, right? One of the first places that we looked was the curriculum guidance, right? Every educational program starts with building a curriculum that's going to guide the ways in which we educate our students, right? In cybersecurity, we have 3 primary curriculum guidance documents. You might all be, hopefully all of you are familiar with them. There is the NICE Cybersecurity Workforce Framework. There is the CSEC 2017 and the CAE, the Centers of Academic Excellence in Cyber Defense Knowledge Units. So there are others, but these are the 3 that are most referred to. They're the 3 that are most used. So these are the 3 that we took a look at to see where we stand, what kind of guidance is available, right? So let me start with the NICE framework. For those of you not familiar with the NICE framework, the NICE framework was developed originally, I believe it was 2012 when it was first published. Developed by the National Initiative for Cybersecurity Education, led by the National Institutes of Standards and Technology. And the idea is to look at the cybersecurity workforce, the cybersecurity landscape, and describe and categorize cybersecurity job functions. Right? There have obviously been revisions on this document. I believe the latest revision was published last year, right? But basically, the core of the document describes the work roles expected or envisioned in cybersecurity and the knowledge, skills, and abilities that are needed to perform those work roles successfully. Okay, so it's a very useful document. And a review of the framework actually shows very little attention to industrial control systems. In fact, the term industrial control systems is not in this document at all, right? The term SCADA, which is sort of a subset of OT, appears in 3 of the KSAs. This is the knowledge, skills, and ability statements. So there are over 1,000 of these, and only in 3 of these, only 3 times, does that specific and possibly the most common reference to industrial control appear. If you look at anything related to critical infrastructure or other terms that could be argued to be relevant to industrial control systems, you get a handful of knowledge, skill, and ability statements, right? So we were curious as to whether this was sufficient for what we were seeing in industry. So we did a really small study. We looked at the 5 most popular job search websites. And we looked for jobs related to ICS security. So this was automation and robotics security, operational technology security, industrial control system security, cybersecurity analysts in industrial control. We used a whole bunch of keywords to search, and then we looked at all of the job calls that we had found, and we narrowed this down, right, to what were the actual work roles we're looking at. And we came up with 10 distinct work roles. For each of those work roles, we looked at the knowledge, skills, abilities, we looked at the tasks, the work tasks. And so I just wanted to show you what we found in terms of knowledge statements. Now you can see from these as compared to, if you map these back to the NICE framework, they're very different. The NICE framework, actually only about less than 1/3 of these are just general cybersecurity statements, right? The majority of them are highly specific to industrial control systems. So somebody would need specific knowledge of both IT and OT in order to be able to complete these tasks, and not just IT or OT, but actually the integration of the 2. So obviously in industry, there is a desire for these work roles, right? So for people who are educated, trained, competent in their ability to carry out industrial control system security work. Okay. The second curriculum guidance document we looked at is called the Curriculum Guidelines for Post-Secondary Degree Programs in Cybersecurity, affectionately known as the CSEC 2017. This document was created by a joint task force composed of the Association for Computing Machinery, so the ACM, the IEEE Computer Society, and the Association for Information Systems, the Special Interest Group on Information Security and Privacy. I think I got that right? And then also the International Federation for Information Processing, their technical committee on information security education. So a lot of notable academic and professional organizations came together. They contributed experts to look at what are the components of a cybersecurity program. What does cybersecurity as an academic discipline look like, right? So they did a whole bunch of workshops, they did online surveys, they talked to a lot of people, and as I recall, something like over 300 people consulted on this, and what they came up with was these 8 knowledge areas, which break down into knowledge units, topics, and learning outcomes, right? And the purpose was to represent the full body of knowledge within the field of cybersecurity. That's what the CSEC 2017 does. Looking for industrial control systems within this document, the term industrial control systems appears as a topic under the knowledge area system security, right? So if you look at a topic, we start with a knowledge unit, then that breaks down to a knowledge area, and then there's a topic, right? So topic, you can think of it as kind of like a module, right? So under system security, right? And SCADA is included under that. The term cyber physical systems appears as a topic under organizational security. Again, a very limited treatment, right? So compare this to what we found in terms of what industry is looking for. This treatment would not be enough for somebody who wanted to go into a role in ICSS. Okay. If you look at the NSA CAE knowledge units, this probably has the most comprehensive treatment of the 3 when it comes to industrial control systems. There's actually an entire knowledge unit that is dedicated to industrial control systems, right? And it actually lays out learning outcomes and topic areas, right? However, if you really examine the topic areas included, they're not really fully representative of what a professional in ICSS would need to know and need to be able to do to be successful, right? So just looking at the curriculum guidance documents, it's obvious that there is a problem. We have a bit of a challenge here. There is not enough curriculum guidance to actually create a full program in industrial control system security, right? So not only are the curriculum guidance documents insufficient, if you look at the landscape of what actually exists, right? So we did a nationwide review and we tried to identify every industrial control system security program certification, right? So we looked for operational technology security, industrial control system security, industrial cyber security, industrial engineering technology security, automation and robotics security, right? We used a lot of terms and we came up with, there are very limited set, right? The most that we found were industrial training programs in cybersecurity that were specific to industrial control systems, right? So GIAC has a bunch of certifications in response industrial defense, critical infrastructure protection, global industrial cybersecurity, right, that are specific to industrial cybersecurity. CISA has a bunch of programs to train people in ICS cybersecurity. ISA has a handful, right? But basically what we found, a lot of programs in cybersecurity, a lot of training in operational technology and industrial control systems, but actual industrial control system security, we found less than 20 training programs, and these training programs vary from a few hours to basically a few months, right? We found less than 10 university certificates. These certificates were anywhere from a few weeks to a year. And we found exactly one degree, one bachelor's degree. It's a 4-year degree in industrial control systems security. I believe it's called Industrial Cybersecurity Engineering Technology, I believe is what it's called. And it was the only one that we could find, right? So obviously there is a bit of a lack right there. So there is, I think we can agree, an educational challenge when it comes to industrial control system security, right? So what we proposed as a solution is the creation of a program of programs. Basically, we need many more in industrial control system security, and we need to create curriculum guidance to help support the development of those programs. So that is what we undertook to do. Basically, the plan was to define the need. I think we can agree the need for this is very clear. We have ongoing cyber attacks. We have these systems becoming more networked and therefore more vulnerable. We have a talent gap, right? We looked at the current landscape and we find that there is definitely not enough education and training. We looked and identified what existing curriculum and existing curriculum guidance was available. So our next step was to actually identify critical knowledge, skills, and abilities that are actually necessary to become proficient in industrial control system security. In order to do that, we undertook a Delphi study. So basically, we reached out to, there is a national industrial control systems community of practice that's actually housed at the Idaho National Labs. I'm a member of that, and I think SPAF is too. A few other people might be as well. And they have some working groups that are working on developing resources, developing standards, and training, and so on, in industrial control system security. But it's professionals from academia, government, and industry. We reached out to them, and we asked them this question: what is the critical knowledge, skills, and what are the abilities that you need to be successful in ICSS? And based on that, based on their feedback, we developed a concept map, which you can see here. This concept map shows what they felt were sort of the core topic areas, the core skills areas in industrial control system security. The second thing we did was we took that concept map and we tried to look at existing programs and see what were the gaps, right? The project we're working on was funded by the Department of Homeland Security in collaboration with researchers at the University of Illinois at Urbana-Champaign. And so they asked us actually to take a hub and spoke approach to this. And so we focused on FEMA Region 5, because that's our FEMA region, and the 6 states, Illinois, Indiana, Minnesota, Michigan, Ohio, Wisconsin, right? In that FEMA region, we looked at a whole bunch of institutions, and basically we surveyed these schools and looked for what existing programs they had. Most of them had some form of cybersecurity, everything from a full degree to a course or modules within courses in cybersecurity or information security. Most of them had fairly decent engineering programs. Some of them had engineering technology programs. And so between all of these, so cybersecurity management, forensics, network security, engineering technology, electrical engineering, industrial engineering, right? So we looked at all of these and tried to identify, okay, so if you wanted to create a program, industrial control system security, what do these things have and what's missing, right? And what we realized are these are the concepts that across the majority of these are missing, right? There's some places that don't have enough cybersecurity, they would need to beef that up. Some places that don't have enough electrical engineering, right? They need to beef that up. But broadly speaking, what was missing was topics on safety, on industrial operations, on instrumentation and control, and especially on security integration. And what we realized is that any program in industrial control system security would need to be ideally interdisciplinary, more realistically multidisciplinary, right? They're going to cross multiple departments, and there are going to have to be some new classes created in these areas in order to fill in the gaps that we're missing, right? So having reviewed these critical concepts and gaps, we created topic areas, right? Created 5 topic areas in risk, governance, information security, industrial control systems, and electrical engineering that we felt if classes hit all of these topic areas and their specific concepts within these topic areas, that would be a reasonable program for industrial control system security. And we went further than that and actually created model curriculum. So we looked at what are the classes that would need to go into an associate's degree, a bachelor's degree, a master's degree, and a PhD in industrial control system security. We based that heavily on classes that already exist. We took into account things like existing credit hour requirements. We took into account things like requirements for general education, right? So we didn't ignore the classes in language and professional writing and so on, communications. There is actually a report on this. I don't think it is currently posted, but it will be within the next few weeks. If you want to see how these classes actually break down, it will be posted as a CERIAS technical report, if anybody is interested. Right. A couple of additional things that I want to note when building programs in industrial control system security. I think it's really important to take advantage as much as possible of the potential for online offerings, right? Now, ICSS, because by its very nature, requires a lot of hands-on work. It's going to require a lot of lab work, but not exclusively. So there are things that students can learn at a distance. And I think having that option would be beneficial to them. And also, much more than many other fields, this is an area of cybersecurity that really needs work integrated learning, right? So any institution trying to create this kind of program is going to have to partner with some sort of industry or military or other critical infrastructure so that their students can get some hands-on learning, some hands-on training in these things, not just lab, but also professional work environment training. And so the program, any program would have to think about how to integrate that professional work into their assessment of the curriculum. Okay, so that's a very sort of high overview of what I think is the educational challenge in industrial control system security. So are there questions?
Professor Ngambeki, thank you very much for your presentation. We are right on time to go to our next segment. Ida's contact information into the chat line, so please do follow up on this or any of the rest of her research that she has there.